Hey guys, I have your notes pulled up for section 9 for day 1, and this is kind of cool. We're going to be looking at infinite areas under a curve, and we're going to try to actually figure out what the area is, even though the area between the curve and the x-axis extends to infinity. And sometimes we're going to have a conclusion like, oh, you know what? No, this isn't possible. The area just keeps growing and growing and growing. It gets out of hand. It diverges. Other times, seems kind of weird, but other times we're going to be able to look at a function and say, no, you know, this really does converge. Like I can find the area under the curve from 0 to infinity. I can actually get a value for that. It's pretty weird. So here's our plan. Here's what we're going to do. We are going to, if we want to look at the area from 0 to infinity, we're going to instead look at the area from 0 to some number, any number along here, any positive x along here. We're going to look at the area from 0 to here, and then we're going to say, okay, that's not good enough. Now let's send this to infinity, okay? So, basically, it's called improper integrals. And basically what we're doing, we're finding the area under the curve from a starting location to infinity. But I can tell you it is 100% completely wrong to write this, to do an antiderivative and just simply sub in infinity. So don't write this down. So doing big F of infinity minus big F of A is not the proper way to do this. If you do that, you're going to lose tons of points on tests and quizzes and AP exam and all kinds of things, and you'll probably get called all kinds of names along the way as well. So we are not going to do that. Here's what we're going to do. We're going to recognize that that's going to infinity, and a lot of times this lower limit is called A, this upper limit is called B. I'm going to kind of stick with those variables throughout this whole section. So I'm going to do a rewrite, and I'm going to say, yeah, we're still going to do an integral. We're still going from A, but this time we're going to go to B of f of x dx, and out in front, I need to send B to infinity. So you got to make sure that you throw that limit there on the front of it. So I'm going to change this to a variable. It doesn't matter what variable you use. And I'm going to send that variable to infinity. And I do this just like normal. I am going to sub in B and I am going to sub in A to my antiderivative. But I'm going to keep in mind that I've got a limit in front of the whole thing that's sending B to infinity. Same way on the next one. This one's fine. I'm going to replace this with a variable, and I'm going to do a limit and send it to negative infinity. Limit, I can call it A. The limit is A goes to negative infinity. The B is fine. And now instead of negative infinity, now my lower limit is going to be A. Pretty easy. And sometimes it seems even more weird, but let's say that a function continues on to negative infinity and on to positive infinity. Let's find the whole entire area. Let's not just start at 0. Let's find the area if you extend it all the way left and all the way right. So this needs to be replaced with a variable that we're going to send to negative infinity. This needs to be replaced with a variable that we're going to send to positive infinity, but I can't do that with the same integral. So I need to split my integral. So where is a good splitting place from negative infinity to positive infinity? Probably 0. 0 is one of my favorite numbers, especially when evaluating an integral. So both of these need to be replaced. So I'll replace this one with A, and I'll say I'm going to do the limit as a approaches negative infinity, right? And we're going to go from basically from negative infinity, we're going to stop it at 0. And then in our next integral, we're going to pick it up at 0 and continue on. Let's stop it at 0. Plus this one picks up at 0. It's going to go to positive infinity, but remember, I'm replacing that with a variable, and out here, I'm going to send that variable to positive infinity. So I've got to go into negative infinity on the left side. We're stopping it at a, picking up at 0, and going to positive infinity on the right side. And then that's basically it. Like, that's basically this whole section. Is recognizing that this is an improper integral. I have to do a rewrite. I have to set it up as the limit of an integral. And then it's basically just, hey, how good are you at evaluating integrals? Like all-encompassing, U substitution, integration by parts, tic-tac-toe, partial fractions. You got all that to think about. How good are you at evaluating an integral? And how good are you at evaluating a limit? Keep in mind, if you get an indeterminate form, we might have to use L'Hopital's rule once in a while. So what I've done is, for those of you who are like, integrals, I got this. Limits, I got this. Should I stop the video and just do the homework on my own, or should I continue the video? Here's what I did. I went ahead and worked out pretty much all the problems. So if you're super good at evaluating integrals, you might just want to just stay on and just kind of watch me go through them. If you're like, not so good, or I could use a refresher just to make sure I've got it. What you might want to do is pause the video, because I'm going to be going probably too fast for you to copy as I go. So feel free to pause the video, copy, catch up, both physically on your paper and mentally, catch up with me, and then restart the video and keep it going. So here we go. Looking at example 1 on page 2, we're looking at the area under the curve from negative infinity to positive infinity under the area under the function e to the x. On each of these problems that I'm giving you, I went ahead and drew the graph. Some of them I knew what the graph looked like. Some of them I had to actually graph them on my graphing calculator. But I hope you can see this. You all know what the graph of e to the x looks like. I wonder if we're able to find the area under the curve and get a value, or if it's just going to keep growing and growing and growing and get out of hand. I kind of think I know the answer before we start, but let's just go through it anyway. So from negative infinity to positive infinity, I recognize both of these need to be replaced with a variable and tack a limit on it, and I have to split it up somewhere between negative infinity and positive infinity, and 0 is my favorite place. Split that up. So here to here, sending that to negative infinity. Pick this one up here, send this one to positive infinity. I went ahead and did my antiderivative and plugged those in at the same time. Kind of 2 steps in one, just because my antiderivative was so stinking easy. So f of this one minus f of this one. And remember, we're actually doing a limit on these terms. Plus, I did my antiderivative, subbed in this, minus antiderivative. Remember, we're doing a limit on these 2 terms. All right, so here, it doesn't matter what a is. E to the 0 is just 1. Okay, minus e to the negative infinity. Well, this is like 1 over e to the infinity power. So you can see that if you look at, because my exponent is negative, my denominator is going to be huge. So 1 over huge is 0. Next one, as b goes to infinity. So e to the infinity is infinity minus e to the 0 is 1. What's the area under the curve e to the x from negative infinity to positive infinity? Infinity. So this diverges. And I mean, I think most of you knew that that was going to happen because look, okay, yeah, the area under this curve gets really small. The area over here, it's just going to keep growing and growing and growing. So you probably knew this, before we even started the math on it. Next one. Our function is 1 over x. I went ahead and drew the entire function. The entire function, it's the curve in quadrants 1 and 3. This problem only wants us to look at the area from 1 to infinity. So forget about this half of the graph. Start here. What's all this area? You can see that it gets smaller and smaller and smaller. We may end up with an answer on this one. Let's find out. So I replaced that with b. I'm sending b to infinity. I do an antiderivative on this. Here's my antiderivative, and I really need to evaluate it from here to here. Sub them in. Natural log of b minus natural log of 1. Okay, and as b goes to infinity, you've got natural log of infinity. Well, if you picture your natural log graph as ln x, as x gets bigger, y gets bigger. This is heading toward infinity. This is 0. Is that right? Natural log of 1? Yeah, that's 0. Turns out we can't find the area, even though it keeps getting more and more tiny, we can't find the area from 1 to infinity under this curve. Next one. Remember, pause the video if I'm going too fast for you. Pause it, copy it, process it. Next one, I've got basically 1 over 1 plus x squared. Honestly, I didn't know what that looked like. I was really interested to look at the graph on that. This is what the graph looks like. Okay, it's not a good drawing because I can't draw, but you can see it gets supposed to get really close to the x-axis out here. It peaks at 1. A y value of 1, and it's supposed to be symmetric and get really close over here. I wonder if we can find the area under this curve from negative infinity to positive infinity. So, called this A, stopped it at 0. Picked this one up at B at 0, called this B, sent B to infinity. Okay, that's the setup. Now it's a matter of antiderivatives, subbing in, evaluating limits. I hope you kind of recognize this as, oh, that's one of those things that, yeah, it's tangent inverse. So the antiderivative is tangent inverse. I got to go from 0 to A, tangent inverse 0 to B. Sub them in. Now, this gets tricky. You have to, first of all, remember what tangent inverse means, and it really helps if you know what the graph of your tangent function looks like. So, let's see, okay. The graph of tangent looks like this. You've got an asymptote here, an asymptote here. That's what your tangent graph looks, one piece of your tangent graph. And When we do inverses, anytime we do an inverse, we answer the question only on this portion. So for example, when I go to evaluate tangent inverse of 0, remember inverse means your places have swapped. This is not your angle. If this were just plain tangent, this would be your angle. This is your fraction. So this question is asking, give me the angle where our tangent fraction is 0. Give me the angle where our tangent fraction is 0. Where is my tangent, my y value? Where's my y value 0? At an angle of 0. So this is 0 and this is 0. All right. Next one. Ready? Give me an angle where my tangent graph heads to negative infinity. So if I sub in negative infinity for this, what angle is my tangent graph headed toward negative infinity? At what angle? Well, can you see that the graph is headed toward negative infinity right here? What is the angle that we are approaching? Negative pi over 2. And for this one, sub in infinity. Remember, this is your fraction. This is your your y value. Give me the angle that the tangent graph is approaching when my tangent is approaching infinity. So as this graph approaches infinity, give me the angle where this is happening, positive pi over 2. So a 0 and a positive pi over 2 and a positive pi over 2 and a 0. Wow. That's kind of wild. That the area under this entire graph, between the graph and the x-axis, from negative infinity to positive infinity, is pi. That's kind of cool. Okay, next one. Graphed it for you so you can see what it looks like. And so yeah, I totally graphed this on my graphing calculator and I was like, oh, it has asymptotes. Pfft, of course it has asymptotes. The denominator factors. So it has an asymptote at -3 and -1. Turns out that's what the pieces look like. All we're concerned with is, what are we concerned with? We just want to look at it from 0 to infinity. So from here on, I wonder if I can get a value for the area under the curve. So here we go. That one's fine. Change that to b. Send b to infinity. Recognize, oh look, this is going to be into partial fractions. I like partial fractions. So I came over here, started doing partial fractions. Right? Set it up. Let x be -1, found my b value. Let x be -3, found my a value. Rewrote it. Did antiderivatives. I knew this was going to be a natural log, and I knew this was going to be a natural log, so did I flip them? I did. I knew this one was going to be negative, and I wanted it to be natural log minus natural log, because I know I'm going to condense them. So I'm just going to flip those around, okay? See, proper notation. I said I'm doing an antiderivative from 0 to b. Don't forget to put that on the end. You can use the vertical bar or you don't have to. Here I go. I condensed them. And then I subbed in. I subbed in b, wrote it out. I subbed in 0 and wrote it out. subbed in B, subbed in Z. Yes? Okay, ready? As B heads toward infinity, as these head toward infinity, you can see that this is a first degree polynomial, this is a first degree polynomial. This fraction right here, forget the log for a minute, this fraction is headed to 1. So as B goes to infinity, this whole thing becomes natural log of 1. And then I went ahead and split it back up because I was like, ooh, I think these natural logs of 1 are going to cancel. So minus, and then I expanded these. Sure enough, these two cancel, distribute your negative. You get natural log of 3. It's kind of cool. The area under that curve from 0 to infinity is natural log of 3. Last one. This is kind of what this graph here looks like, and it never goes negative. So, well, on this side, of course, it never goes negative. So if we're looking at it from here to here, am I looking at it from there to there? Yeah, from 1 to infinity. So from 1 to infinity, this is always going to be positive. You know that this is never 0 or never negative, so it's just going to get super close to the x-axis. By the way, I forgot about something. Let me back up here. I dropped my absolute value symbols, and I did it on purpose, but then I forgot to talk about it. I love dropping absolute value symbols when it's legal. I got to be careful when I drop the absolute value symbol, so I really have to think it through. So I looked at this, I was like, oh, I want to drop these stupid things. I hate writing them and I hate doing them. Can I drop them? Well, yeah, I can drop them because, why? Why can I drop them? We are only looking at this from x equals 0 to x equals infinity. We never want to look at any negative x values. So if x is always 0 or larger, this is going to be an issue. Because this quantity in here is going to be positive anyway. Same here. So after thinking that through, I dropped them. Warning, when you're doing an antiderivative, they have to go on. But if you can legally drop them after that, you're allowed to do that. Okay. Back to this one. So I called that B, set it up. Recognize, oh, this is a tic-tac-toe problem. So I set up my table. Oh, no. I was like, oh my gosh, I did this wrong. No, I didn't. I did the little tic-tac-toe thing. There we go. And that's what I wrote from here to here. Subbed them in. Oh, and by the way, as I was subbing them in, since that was a negative B, I was like, I don't want to deal with that, so I put it under. Negative B, I put it under. And then when I subbed in 1, I put it, that was a negative 1, I put it under. That was a negative 1, I put it under. So as B heads toward infinity, ooh, look at this, look at this, look at this. This is infinity over infinity. L'Hopital. This one's going to be fine. This one's going to be fine. This one's going to be fine. I had to do L'Hopital on this one. So, derivative, derivative, try it again. Same, same, same. Negative 1 over huge, 1 over huge, 2 over e. The area under the curve, where was it? From 1 to infinity is 2 divided by 2.7-ish. You can actually find the area under that curve. That's pretty cool. All right, so the big thing about this section is remembering that you cannot do big F of infinity minus big F of A. I had one student last year, I think, really smart guy. He just totally ignored improper integrals. Like, these were on the test, and he just kept doing. He never did a limit, and he bombed that test. Buddy, what the heck? He's like, I just spaced on it. So of course, I mean, he did a retake and he got like 100 on it. So it was fine. The biggest thing is, remember, you cannot like do an integral when you've got infinity in there. You have to replace it with a variable and set up your limit. Do not forget that. Good luck.